of the magnitude q, and they are separated by a distance a. Find potential energy of the system. Solve this and write your answer in chat, and I'll modify this question. Find the potential energy of the system. Have you got the answer? So there are three charges. That means there are three pairs. For the first two pair, I can write kq squared by a. For these two pair, I can write kq squared by a. For this and this, I can write kq squared by 2a. That will give me 5 by 2 kq squared by a. Where k is of course 1 by 4 pi epsilon naught. Now let us say this is the initial state of the system, and you have the same three charges, and you have rearranged in them in this manner, such that the three charges are in the form of a triangle. Three charges on the coordinates of an equilateral triangle of side A. Find the potential energy of the system in this case. What's the value of potential energy here? Rishit, tell me the answer.
3kq square by a.
3kq square by a. That is correct. Now, this was the initial potential energy, and this is the final potential energy. Suppose you want to rearrange the system from this state, this initial state, to this final state. Then find the amount of work done. Find the amount of work done to rearrange the charges. Find the amount of work done to rearrange the charges. Solve this part. To rearrange this, you have to do some work externally. Potential energy has already been calculated. How will you relate it to work done? Nihar, can you tell me the amount of work done?
Just 2 seconds, sir.
What did you say?
Just a second, sir.
Okay. What is the answer for this? Nihal, have you solved it? Apurav, can you tell me the answer?
Sir, KQ square by 2A.
KQ square by 2A. That seems correct. The work done by external agent is final potential energy minus the initial potential energy. So final potential energy is 3kq square by A, and initial potential energy is 5 by 2 kq square by A. So that is correct. Kq square by 2A, where k is 1 by 4 by epsilon naught. Good. Suppose I have two charges arranged like this. We have plus 5 NC. Okay, see this. Some students made mistake in this exam. So this is NC. N is nanocoulomb. Nano is 10 to the power minus 9 coulomb. 1 nanocoulomb is 10 to the power minus 9 coulomb. So I have one charge as 5 nanocoulomb and another charge as, call it 2 nanocoulomb minus. The distance between these 2 points is 7 meter. Then find the point at which potential is 0. Find the point at which potential is 0. The point should lie along this line joining only. Nanocoulomb is 10 raised to minus 9 coulomb. So in this case, there are three possibilities. It is possible that the point lies on this side. The point lies on this side. Let us see if that is possible. Let us say this point is x meter, x distance away from it. And so if I write the potential at this point P, it will be k into q by x minus k into q by x. So if I calculate this, 5 by x, this will be x plus 7. No? Instead of 7, it will be 7 plus x. If you solve this, it's not possible, I think. X will come out to be negative. So this case is not possible. Okay, this case is not possible. Second case we can take, in which I can choose the point to lie in between somewhere here. So if I call this x, then this will be 7 minus x. So potential at point P here would be k into 5 by x minus 2 divided by 7 minus x. To solve this, from here we are getting x is equal to 5 meter. X is equal to 5 meter is a possibility. So this case is possible. Here this case was not possible because x was coming negative. So here x is equal to 5 meter is one of the solutions. You have to also check for this side beyond minus 2 nanocoulomb. So let us say the point is here, point P. So this distance is 7 meter and this is given as x. So potential at point P will be, taking k common, q by 7 plus x minus q by x. This should be 0. So 5x equals to, from here we're getting x is equal to 14 by 3 meters. So this is also possible. This is also a possible case. So in this case, there are 2 points where potential is 0. First is in between and second is beyond the lesser amount of charge, minus 2 nanocoulomb. Any questions regarding this?
No, sir.
Okay. I'll give you a similar question again. Let us see if you can make it right. This time I have 7 coulomb here and 3 coulomb here. And they are separated by a distance of, let us say, 10 meters. Find points at which potential is 0. This charge is negative. This charge is negative. Find the points at which potential is 0. Rishit, have you got the answer?
Yes, sir. X is equal to 7.5 and x is equal to 17.5.
X is equal to 7 by 5 and 17.5.
7.5, 17.5.
Okay. So I think the first point should be here somewhere. Let me call this distance as x. So potential at point P, it will be k into 7 by x. If this is x, then this should be 10 minus x. So minus 3 divided by 10 minus x. This should be equal to 0. So 17 minus 7x is equal to minus 3x. So from here, x will be 7 meters. So this point would be 7 meter away from the 7 coulomb charge. And let us take another point q. So the point q should be near the negative charge because negative charge has a smaller magnitude. And potential at point q is 0. Let us take this distance as y. So potential at point q, that will be 7 by 10 plus y minus of 3 divided by y. This should be equal to 0. So I'm getting 4y equals to 30. That will give me 30 by 4, 15 by 2. So 7.5. Okay, so this point is 7.5 meters away from the -3 coulomb charge, or 17.5 meters away from this charge, and this point is 7 meters away from the 7 coulomb charge. 7.5 meters away from 3 coulomb, and it will be 17.5 meters away from 7 coulomb charge. This answer is correct. If you have doubt, you can ask. Next question. Suppose there are 6 charges arranged in the form of a regular hexagon. A regular hexagon has all the sides as equal, and the internal angle in the regular hexagon is 120 degrees. So we have 6 point charges, and the charges are like this. The side of each side is it's a regular hexagon, and each side has length a. In this case, you have to find the potential at center O. Find potential at the center O. Nihar, can you tell me the answer? What is the net potential at the center?
So, no, no,
Yeah,
hello,
yes,
hello,
yes, you're audible. Tell me the answer.
hello,
Hello.
hello, sir, hello. My internet.
Apurav, can you tell me the answer for this?
Sir, I'm a bit confused because of angles.
Because of
Angles, I am not able to understand what will be the distance.
okay. See, it's the regular hexagon. Regular hexagon means all the sides are equal. All the sides are equal, and all the angles are 120 degrees. That means a regular hexagon is made up of 6 equilateral triangles, like this. If all the angles are equal, I join these lines. All the internal angles, they are 60 degrees. This angles are 120 degrees, 60 plus 60. So that means all angles are equilateral. So if this side is A, all sides are A, as well as this line's distance between the charge and the center, that is also A. And all these triangles, the small triangles, they are equilateral triangles. This happens whenever I say a regular hexagon. Now can you solve it, Apurav?
Yes, sir, now I will.
Okay. Solve it, tell me the answer.
Sir, I think it will be K phi Q minus Q by A and K 2Q minus Q by A, something like that.
So potential is KQ upon R. So I can take K as common. If I start from this point, 2Q and point O, they are separated by a distance A. So 2Q by A, all the points are separated by a distance A with the charge. I can even take the A common and add up the charges. So 2Q minus Q minus Q plus Q minus Q plus 5Q. Because all the charges are A distance away from the, this point is A distance away from all the charges. So this gets cancelled out and the final answer is just 5KQ by A. This is the potential at point O. Is this clear?
Yes, sir.
Okay. Next part of the same question. Find work done in bringing a charge Q naught from infinity to O. You're bringing a charge Q naught from infinity to O to find the work done.
Sir, what should we take potential at infinity?
Potential at infinity is taken as 0. If it is not given, potential at infinity is 0.
Sir, 5KQ Q naught by A.
5KQ Q naught by A. Correct. Good. So work done by external agent is equal to Q times Q naught times the final potential minus the initial potential. So initial potential is at infinity and final potential is at point O. So this will be Q naught into potential at final potential is 5KQ by A and initial potential is 0 because at infinity we consider the potential to be 0. So this is correct. 5KQ Q naught by A. This is the answer. There is a charge of 5 coulomb here and a charge of minus 5 coulomb here. At the center, there's a charge given as 7 millicoulomb. And you want to move this charge from point A to point B. The distances are given. Take this as 10 centimeter. This is also 10 centimeter. And this distance is given as 10 root 3 centimeter. The question is, Find work done in moving 7 millicoulomb charge from point A to B. Find work done in moving the 7 millicoulomb charge from A to B. These two charges are fixed. This 5 coulomb is fixed. This minus 5 coulomb is also fixed. Nihar, I'm hoping an answer from you. If your mic is not working, you can reply in the chat. The formulas here, the work done is equal to final potential energy minus initial potential energy. Potential due to a single point, you know the formula is KQ upon K. There are only two formulas that we are using here. Solve this. Nihar, can you tell me the initial potential first? Seven KQ by 300. Five KQ on. Okay. See here. Let me solve this. First, I will calculate the potential at point A. So potential at point A, that will be K into 5 coulomb by 10 centimeter and minus 5 coulomb by 10 centimeter. So potential at A is 0 because it is equally placed between two. It is equidistant from a positive charge and a negative charge. I can also find potential at point B, and this distance, if you calculate, it is 20 centimeter. Again, potential will be 5 coulomb by 20 centimeter minus 5 coulomb by 20 centimeter. Again, the potential is 0. So work done will be 7 millicoulomb into final potential minus initial potential. Final potential is potential at point B, and initial potential is potential at point A. They both are zeros, so work done by external agent will be 0. Work done is therefore 0. Are there any questions about this? Have you tried by any other method?
Sir, if in place of minus 5 coulomb, there will be positive 5 coulomb, the answer will be same.
No, then the answer would be different. Because potential will be non-zero in that case.
It will be 5 coulomb plus 5 coulomb by 10
Yes,
centimeter.
yes. That answer would be different. Let us solve another problem like this. I hope if there are any questions, then please ask. This is a very simple question. But yeah, only if your concept is clear. Suppose you have a charge Q here and another charge Q here. This is point A and this is point B. This distance is A and this distance is also A. And this is given to you as root 2A, or let us take it root 3A. Then you have to find work done in moving charge Q naught from A to B. This time it will not be zero. Both charges are positive. So remember to follow the correct steps. Tell me the final answer. Rishit, it's your turn. Once you are done, you have to tell me that you are done, and then, or you can write the answer in chat. Done.
Yes, sir. Minus Q naught K divided by A.
Minus Q naught K divided by A. Okay, this seems correct. By A or by 2A?
By
By
A.
Okay. So first I'll calculate the initial potential. So potential at point A. So that will be K by A Q plus Q. So that is 2K Q by A. And potential at point B, it will be, if this is A, this is root 3A. This distance will be 2A. So it will be K by 2A and Q plus Q. So it will be KQ by A. So work done will be equal to Q naught into final potential minus initial potential. Q naught is given as Q naught only, VB minus VA will be KQ by A. 2KQ by A minus KQ by A. So Prishit answer is correct. It will be KQ naught Q by A. This is perfect. Okay, next question. So three charges they're kept on the side of an equilateral triangle of side A. Let us give some values. Q is 4 microcoulomb. And value of A is given as call it 10 millimeter. So this is the initial system. Then what you want to do, find the work done by external agent if The charges are now placed at 20 millimeter distance from each other. This means earlier the A was 10 millimeter. Now, later, the value of A is 20 millimeter. So basically, you are getting the triangle bigger. This was the initial state. In the final state, what you are doing, you're getting a bigger triangle. So you're separating them. If you're trying to separate it, then there will be some energy involved, some work involved. So from A to 2A now, this bigger triangle is 2A. Charges, magnitude of charges is the same, but the side length has increased from A to 2A. Find the work done by external agent if the charges are now placed at 20 millimeter distance from each other. So there will be some initial potential energy of the system, some final potential energy of the system, and then the work done will be the change in potential energy of the system. Find this out. If you want the value of K, the value of K can be taken as 9 into 10 to the power 9, the SI unit. Newton meter square per coulomb square. Value of K is 9 into 10 raised to 9. So here initial potential energy will be 3 kq square by A because there are 3 pairs. And the final, because you have separated them by now 2A distance, so it will be 3 kq square by 2A. The work done will be final potential energy minus the initial potential energy. So that will be minus 3 kq square by 2. K is 9 to 10 to the power 9. Charge is given as 4 microcoulomb. So 4 into 10 raised to minus 6 into 4 into 10 raised to minus 6. That thing divided by A is 10 millimeter. Millimeter is 10 raised to minus 3. All we have to do is solve this. Nine minus 6 is 3. 3 minus 6 is minus 3. That is giving me minus 21.6 joules. Anybody can confirm this answer? Do your own calculation, but confirm this answer.
Yes, sir, same answer.
Okay, good. Suppose we have a water drop and charge on the surface of this drop is 1 microcoulomb, take 2 microcoulomb. The radius is 10 millimeter. Or let me take another one. Charge on this surface of this drop is, let us say, 2q, and the radius is, call it 8r. Take value of q as 1 microcoulomb and value of r as 1 millimeter. And find potential at the center of this water drop. Find potential at the center. Oh, you can consider this as a hollow spherical shell. Although it is filled up with water, consider this a water droplet in space. In space, if a sphere is charged, then the charges will try to occupy the maximum distance between each other. So it's like a charged spherical shell. All the charges on the surface. Find the potential at the center O. Take K as 9 into 10 raised to 9. What's the value of the potential at the center? At the center of the spherical shell, it is K Q upon R. So if I calculate the value, K is 9 to 10 raised to 9, Q is microcoulomb, and R is 1 millimeter, but it is 2Q, so 2 into 10 raised to minus 6, and this is 8R. So 2.25 into 10 raised to 6. joules per coulomb. Is that right? Anybody got this answer? Any doubts in this?
Yes, sir, no doubts.
Okay. Suppose this droplet is divided into half. This is made into two drops. Two drops of equal volumes, or two drops having equal radius. And charge is equally divided. So now let us say this has charge q dash, and now the new radius is r dash. Then find the potential at the center of each droplet. Find potential at center of each droplet. That is at O dash. For that, you have to first find the charge q dash and the radius r dash. And that potential at O dash will be k q dash by r dash. So you have to conserve the volume of the liquid as well as conserve the charge. This is the property of conservation of charge. First thing is here, the charge will be divided. So the new charge will be half of the original charge. So 2 microcoulomb will be divided equally. So charge will be 1 microcoulomb on each of them. And the volume is also divided to the new volume. So original volume had radius 2r, no 8r. This had radius 8r. So from here, 8r cube is equal to twice of r dash cube. This is 2 raised to 9, 2 raised to 8. So r dash will come out to be 2 raised to 8 by 3r. Okay, that is a complicated number. Okay, how we can find the potential? It's 9 into 10 raised to 9. Charge will be 1 microcoulomb divided by 2 raised to 8 by 3. That was in the wrong number. So R is 1 millimeter. This was micro. So 9 by 2 raised to 8 by 3. Okay. Into 10 raised to power 6 joules. So here, remember, the radius will not be halved. The radius will not be halved. The volume is getting divided. So initial volume will be equal to the final volume. I'm going to do this calculation. This has become difficult. Any doubt in this? Okay. Suppose there is a region of uniform electric field. The value of electric field is 10 volt per meter. Or let me give it as 10 volt per centimeter. And you want to move a charge from point A to point B, which are separated by a distance of 10 centimeter. Find, first thing is find VB if VA is given as 200 volt. Solve it. Find VB, VC, VD and VE, all these four potentials. Apurav, can you tell me the potential at point B?
One second.
Yeah.
Sir, I forgot to convert centimeter into meter.
No need to do that. See, this is given in volt per centimeter already. So I can write VB minus VA That will be equal to minus of E into RB minus RA. So VB and VA is given as 200 volt and E is given as 10 volt per centimeter. This is already given in centimeter. So that is RB minus RA is 10 centimeter. They get cancelled. They cancel each other out. So VB will be 200 minus 100. That will be 100 volt. Okay.
Yes, sir.
Similarly, calculate potential at point C. Harshit, have we calculated the potential at point C?
Yes, sir, 500.
500. See, it should be decreasing.
There
No?
is
Here it is 200.
700.
Sir, minus 100 volt.
Minus 100 volt is correct. The potential should continuously decrease. And what about potential at point D?
Sir, same as B.
Yeah, correct.
100 volt.
And potential at point E? Same as
Same.
point C. Then third question is work done in bringing a 1 coulomb charge from B to A. So work done is Q into final point is A, initial point is B. So final minus initial, always remember that, VA minus VB. Calculate this value and tell me. What's the answer for this?
100.
100 joules. So 1 coulomb into VA minus VB. That is 200 minus 100. For potential can be written as joules per coulomb. So that is 100 joules. So positive work is done. Okay. So these are the questions. And again, you have to complete the worksheets. Apurav and Rishit has set the worksheet. For Nupur, I will taking the cover up classes and then you have to submit the worksheet after that. But Nihar, you really have to pull up and start giving the tests and the homeworks. You haven't submitted any.
So we'll be giving my test till tomorrow.
Okay. And Apurav and Rishit, are you facing any problems in the questions from the book?
No,
No,
sir.
sir, not till now.
Okay. If you face it, if you're facing any problems, then we can discuss it in the next class. If not, we'll start with a new chapter, that is conductors and dielectrics and capacitors. Right now you have a formula test. So in the formula test, there are 10 questions and you'll be getting 10 minutes to solve it. It will be present on the screen. So it will be starting in 2 minutes, and make sure that you submit the answers to me privately and the private messages, and answers which are off, if you send to me after 8:35, it will not be considered. So there's just one line questions and you just have to write the formulas, nothing else. Any questions about formula test?
So this is for which chapter?
This is for the 3 chapters we have studied. No? You didn't know about the formula test? It was in schedule.
No, it was scheduled,
Mm-hmm.
but I didn't know the portion.
Okay. Don't worry, you have studied. It will not be that difficult. We'll be starting it right now. Any other question?
No, sir.
Can you see the screen? Hello.
Yes, sir.
Yes, sir.
Okay. Okay. Start with the
Yes, sir.
solving the problems. You got 10 minutes. And send the
Same
answer.
questions for me.
Yeah, same questions for you. The last question is potential energy of an electric dipole in uniform electric field. You have to click the pictures of the answers and send me on the WhatsApp.